Discussions about artificial intelligence can get very emotional, but what are we actually talking about? Is intelligence a special trait of humans? After all, we call ourselves Homo sapiens. But if so, do we really know what it means to be human? For example, we can all agree that humans are conscious, but we don't really know how that works, do we? So talking about conscious machines can get very confusing. But maybe intelligence is less about being like a human, but rather about intelligent actions. Imagine you want to build a machine that can fly. To fly does not mean to be like a bird. We don't need to have feathers or lay eggs. Instead, we must explore aerodynamics to build flying machines. And just like a machine can fly without being like a bird, a machine can act intelligently without being like a human. This argument is from the classic textbook on AI by Stuart Russel and Peter Norvig called Artificial Intelligence: A Modern Approach. According to Russel and Norvig, AI is about agents that receive information from their environment, process it, and take action to make things better. It is this rational action that is the essence of intelligence. Many things can act as an intelligent agent. A worm, a dog, humans of course, but also organizations made of many people. They all receive information from their environment and act accordingly. And this is where things get exciting, because as we've seen in the last video, computers can do that too. So with computers, we can build intelligent machines. And this is how it's done. Let's say we want to build an intelligent machine that can clean up our desk. To do that, we need to understand the necessary steps of this task. So how would we clean up our desk? Well, at first, we would need to know what is there. We must identify objects and their relationships. In our case, that's a couple of books, pens, a cup of coffee, a computer, etc. Now that we know what is there, we can think about it and make predictions. For example, we might conclude that putting a cup of coffee too close to a computer is a bad idea. But we can't know everything, and things might change. So we must be able to learn and adapt to improve our decisions about what goes where. Of course, in order to make good decisions, we need a clear goal. If we say that we just want to have a clean desk, well, we might as well just shove everything off the table. Obviously, that's not what we want. So we need to be very specific when we define those goals. And those goals might not even be clear in the beginning, or they might change over time. So whoever cleans up the desk needs to communicate with the person who uses it. Finally, we need a plan of action and do it. Now that we have a clear understanding or model of what our machine should do, we can go ahead and build it. To do that, we simply automate each step of our model. At first, we need cameras, microphones, and other sensors to gather data about our desk. Then we need to analyze that raw data and turn it into knowledge. We can represent this knowledge in computer languages and databases so that it is accessible for reasoning. Logic is a way to reason about the world. It lets us play out in our minds or in a piece of software how situations could unfold. And when our information about the world is incomplete, we can deal with this uncertainty and work with probabilities. Machine learning helps a computer to adapt and make decisions based on data. Human-computer interaction lets us communicate with those machines to tell them what we want. And to do that, they must be able to arrange a plan of action. And of course, we need physical devices that can carry out this plan in the real world. Then we can build an intelligent machine, which means a machine that can take rational action and clean up our desk. So the core idea behind all of this is the alternation between abstraction and application. At first, we analyze how something works in the real world, and then based on that model, we can build machines that can perform that action. So we go from the real world to an abstract theoretical model, and then back to the real world with a practical application. It is this feedback loop which I find most fascinating about AI, because it is one thing to have an interesting argument about how our minds work, but quite another to be able to try out these theories in the real world. Philosophers and psychologists can use AI as a practical craft to test their ideas. In return, computer engineers can build on insights gained by the humanities. In AI, different disciplines can exchange their ideas. Over the last 70 years, AI has seen its ups and downs, with hypes and promises, followed by setbacks and disappointments. These trends also depend on how useful AI appears to be. Currently, we see a lot of useful applications like self-driving cars, creepy robots, search algorithms, language translation, medical diagnosis, computer gaming, and so on. Many of these solutions are based on improvements on how machines learn. Like and subscribe to see how that works in the next video.